So once again, we're doing 4.2 logarithmic functions. So in this case right here, we are going to write this logarithm as an exponential equivalent. So this right here is your base. So we have 5 as the base of your exponent. And we know that the exponent of this base is going to be this number right here, which is a 3. And then we are going to write that as equivalent to 125. And we can verify this if we wanted to, right? Because 5 to the third power is 5 times 5, which is 25, times 5, which is 125. Check. All right, we'll try this one, the same kind of thing. We know the base of this one is 4, so we write down the 4. We know that the exponent must be a 9, because that's the number right over here, right? And then m must be what the whole thing is equal to, an m. Over here we have 7 to the second power is equal to 49. If I write that as a logarithm, we're going to have a log, right? But base 7, okay, the argument is 49. And we have 2, which is the exponent. We can verify, right? 7 to the second power is 49. Check. Or put another way, 7 to what power is 49? 2. Awesome. Okay. Over here, this one's going to be a little more complicated, but not too much. We might have to do a little bit of a conversion on this one, but let's see. So let's say we're saying log. And what's the base of this? Well, it's going to be the 3, so it's log base 3. And what is it equal to? Well, it's equal to 1 over 81. And what's the exponent? It is a negative 4. Negative 4. All right, so far so good. Okay, so now we're going to find the exact value of the logarithm, but without using a calculator. Okay, so here we go. Now, I'm going to convert these to exponents first, but you don't have to. I'm just going to do this to kind of illustrate it better. So let's say we had 7, that's the base, and the question is what power, right? What power would that have to be to get 343? And the answer to that is, well, 7 times 7 is 49, right? And times 7 is 343. So this would have to be 7 to the third power to get it to be 343. So we would just end up having this as 3, right? So the exponent would be 3. 7 to the third power is 243. So this one over here, same kind of question. Again, you don't actually have to write all this out, but this is the concept behind it. So we were saying 3 to what power is 729. Okay, so again, 3 to what power is 729. You can just keep on multiplying it until you get to 729. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. Okay, so how many did we get, right? So we went from 3, 9, 27, 81, 243, 729, right? So we end up with 3. So we end up with 3 to the 6th power is equal to 729. Okay, so over here, this one might require a little bit of moving things around, but we have a base of 3, but we don't know what power we need to bring that to get it to go to 1 over 27. Very quickly, let's go back over here. So it looks like that's equal to 6, right? 3 to the 6th power is 729. And you can use your calculator for this. You don't actually do it all mentally or anything like that. So, and because we end up with a fraction, we can actually move this around a little bit. So for instance, if we do the prime factorization, so right here, we would put that over, for instance, 3 to the 3rd power. But since it's in the denominator, if we put it back on top, it turns negative, right? So we would have that be 3 to the negative 3rd power, right? So 3 what? 3 to the negative 3rd power. All right, so we know this must be negative 3. Now the same thing I did here as far as moving things around and do the prime factorization, you can do to all the other ones. So another way to look at this is 7 to, what power is equal to 743? Well, that's 7 to the 3rd power, right? So 7 to what power? 7 to the 3rd power. Over here, same kind of thing. We do a prime factorization, right? So same question, but we can look at it in terms of prime factorization, right? This would be 3 to the 6th power. So as long as you do the prime factorization and it goes in evenly, then this trick will work pretty nicely. Okay, let's try a couple more. So right here, question is 3 to what power would give you 1 over the square root of 3? Okay, so let's rewrite this. So we have 3 to what power is equal to 1 over the square root of 3. Now the square root of 3 is the same as 1 over 3 to the 1/2 power, right? Okay, and now we're going to pull this denominator, we're going to put it on the top. That's going to flip the sign to 3 not to the positive 1/2, but the negative 1/2. So 3 to what power is equal to this? 3 to the negative 1/2 power. So put negative 1/2. Not too bad, right? Okay, so over here we say 3 to, right, so the base is 3. So 3 to what power would give me 3 to the second power? Well, that's funny. So again, 3 to what power is equal to 3 to the second power? Well, I'm gonna put a, so this looks like this is going to be a 2, right? 3 to the second power is equal to 3 to the second power. Okay, and over here, this one's a bit different, in that if these bases are the same, then it's just equal to 5. So this one right here is a little bit different. You're going to learn this trick later on more, but basically right now it's good enough to realize that if this base and this base are the same, then it's going to be equal to 5.